Rocket Factory Augsburg, or RFA for short, is a German space startup building an orbital-class launch vehicle called RFA ONE. The rocket is now fully assembled and standing on the launch pad at SaxaVord, a small island off the coast of Scotland. RFA could launch as early as August, once a hot fire test is completed. The company has already received its marine license and, in 2025, was granted a spaceflight operator license by the UK's Civil Aviation Authority, the British equivalent of the FAA. SaxaVord itself is licensed for vertical launches, so if the hot fire goes well, we could see the first commercial orbital launch from the UK in just a few weeks. I'll quickly cover RFA's milestones, then move into a head-to-head comparison between the two European launch providers planning to fly later this year, RFA and Isar Aerospace. The prize is the first successful orbital launch by a European private company. Key milestones for RFA. In January 2023, RFA selected SaxaVord as the spaceport for its first launch and secured exclusive access to Pad Fredo. Other companies also planning to fly from SaxaVord include Skyrover, High Impulse, and possibly Latitude Space. In 2024, a pad incident destroyed RFA's first stage and all 9 engines, and caused damage to the launch pad. In 2025, the company received its spaceflight operator license from the UK Civil Aviation Authority. This year, they are back on the pad with a fully assembled rocket fitted with 9 new engines. It's worth noting that while the current focus is on RFA ONE, the company has already successfully hot-fired their Helix 2.0 turbopump and pre-burners. This is a future higher thrust engine intended to power a more capable rocket. Let's briefly talk about their engines. RFA has chosen an oxygen-rich stage combustion engine cycle. This is a more complex design than the engines used by many other European launch providers, including Isar Aerospace, but more on that later. Their propellants are RP1 and liquid oxygen. Thanks to these high-performance engines, RFA ONE can deliver up to 1,300 kilos of payload into orbit. That puts it at the upper end of the European small launcher class. For comparison, Rocket Lab's Electron has a maximum payload capacity of around 300 kilos. RFA ONE Orbital Launch Vehicle. RFA ONE is a 3-stage vehicle. The first stage is powered by 9 Helix oxygen-rich stage combustion engines. The second stage, also Helix powered, has already completed a successful hot fire campaign. The third stage, called Redshift, is an orbital transfer vehicle designed for precise payload delivery. Performance is rated at up to 1,300 kilos to a 500 kilometer polar or sun-synchronous orbit. Now let's talk about what happened in 2024. Hot Fire Campaign 2024. RFA originally planned to launch in 2023. After some delays, the company was ready to begin its launch campaign in 2024. The final step was a full 9-engine hot fire to qualify the vehicle. On the 19th of August 2024, during the first attempt to fire all 9 engines, something went wrong. An investigation found that an oxygen fire inside one of the turbopumps was the root cause. RFA described the event as very unusual and difficult to contain. A fire jet burst from the side of the stage and the flames quickly spread to neighbouring engines. Although the fire suppression system activated, it was not sized to deal with an oxygen-fed fire of that intensity. The kerosene fuel then ignited, creating a large blaze that engulfed the entire booster. The result was a total loss of the first stage and all 9 engines. The launch pad sustained damage, but was later repaired. RFA and SaxaVord learned a great deal from the incident and have since made improvements to the engines, systems, and operating procedures. SaxaVord, the spaceport operator, noted that anomalies during testing are inevitable and that more will likely occur. Accidents are part of rocket development. Both SaxaVord and RFA remain fully licensed by the UK Civil Aviation Authority to conduct launches from the site. Now, let's compare RFA with Isar Aerospace, another German space startup racing to reach orbit and become the first private company to do so from European soil. RFA and Isar Aerospace engines. There's a clear difference between these two launch providers when we look at their engines and fuel choice. This will have long-term implications, so let's examine it in some detail. RFA has chosen a complex engine cycle, oxygen-rich staged combustion, the same cycle Blue Origin uses on its New Glenn vehicle. In contrast, Isar Aerospace has gone with a traditional and simpler design, the gas generator cycle. RFA's engines deliver higher performance, giving them greater mass to orbit, around 1,300 kilos, compared with Isar's 1,000 kilos. That advantage comes at the cost of complexity. As we saw with RFA's 2024 pad accident and with Blue Origin's own recent engine-related issues, complex engines can have disastrous failure modes. Both companies use liquid oxygen as the oxidizer, so the main practical difference is the fuel. RFA uses RP1, the same fuel as the Merlin engines on Falcon 9. Isar uses propane. RP1 can be stored at ambient temperature, while propane is mildly cryogenic and needs to be kept at around -42 degrees Celsius. RP1 can cause coking in the engine, whereas propane burns more cleanly. Both are relatively straightforward fuels to handle compared with liquid methane or hydrogen. Isar launched for the first time in March 2025. The flight lasted only about 30 seconds before the vehicle lost control, crashed and exploded. Still, it provided valuable data that couldn't be obtained any other way. First flights are rarely fully successful, especially for space startups. Isar has now had over a year to learn from that flight and make adjustments. RFA, on the other hand, is only now back on the pad ready for fully integrated testing, largely because of the 2024 explosion. That delay can be partly explained by the more complex engine cycle, which operates in an extremely corrosive oxygen-rich environment with high-speed turbo machinery and therefore has more potential failure modes. This is really a difference in philosophy. One approach prioritizes simpler, faster to develop technology to reach flight sooner. The other accepts greater complexity and longer development time in exchange for higher performance engines that should deliver long-term advantages. If it weren't for several scrubbed attempts earlier this year, Isar could already have flown a second time. The simplicity of their engine allows faster iteration and more rapid design test fix cycles. RFA's engines, once fully matured, should offer superior performance and higher payloads. The company is paying an upfront cost in time and risk to develop a high-performance engine that can later power much larger vehicles carrying more lucrative payloads. Simpler engines can deliver early benefits, but they are less well suited to scaling into larger, highly competitive vehicles. Let's look at another key differentiator between these two companies. Launch sites. Launch site selection is another clear distinction between these two companies. RFA has chosen SaxaVord, a spaceport on Unst, a small island off the northern coast of Scotland. At around 60 degrees north, the rockets can launch efficiently into orbits of 60 degrees inclination and higher. Isar Aerospace has a launch pad at Andøya in Norway. This is deep in the Arctic, at a latitude of 69 degrees latitude. Due to range restrictions, it can only launch missions to inclinations between 90 and 110 degrees. That covers the popular sun-synchronous and polar orbits, but it cannot support mid-inclination or lower orbits. The icy conditions, extreme cold, strong winds, and very limited winter daylight at Andøya restrict launch cadence and make logistics and day-to-day operations more difficult. RFA, by contrast, operates in more benign weather conditions and can support a much wider range of mission profiles. While most customers prefer sun-synchronous orbits, some Earth observation missions over Europe or other regions need lower inclinations. For practical purposes, those missions are impossible for Isar to serve from Andøya. RFA's advantage. Looking ahead, most launch providers will start with small vehicles, but to become truly profitable, they eventually need to move to larger ones. Even Rocket Lab, the clear leader in the smallsat sector, makes around 2/3 of its revenue from services, satellite platforms, and components, not from launches themselves. RFA has a clear lead here, with its high-performance Helix engines, which are already based on a cycle that can power larger rockets. Blue Origin's New Glenn uses the same oxygen-rich stage combustion cycle, and so does Rocket Lab's upcoming Neutron vehicle. Isar Aerospace, by contrast, would need to develop an entirely new engine to power a competitive medium-lift vehicle. Gas-generator engines are simply less competitive today for larger vehicles. Their performance is outclassed by oxygen-rich or full-flow stage combustion designs. RFA also has wider operational flexibility, allowing it to serve more customers and more benign weather conditions than Isar, which should support a higher flight cadence. Realistically, heavy and super heavy launch vehicles flying from Europe have very few suitable locations. Overflight risk makes it unsafe to launch large rockets from most of continental Europe. In practice, the viable sites are limited to northern Scotland or parts of Scandinavia. Launching from a floating platform in the North Sea is not practical for heavier vehicles. Sea conditions would limit cadence and drive up logistics costs. RFA already has a license to operate from the UK, has received UK funding, and has built the political and commercial relationships needed to work there. Isar is a Munich-based company with no significant UK presence. Its only current European spaceport is in Norway, and any move to larger vehicles would require a long development program for more powerful engines. RFA is well placed for constellation management tasks, replenishing or adjusting European constellations such as Galileo and IRIS-2, as well as other defense or communication satellites. Its three-stage design with the redshift orbital transfer vehicle allows more precise satellite placement than Isar's two-stage vehicle. In short, RFA offers greater flexibility, more frequent launches, larger payloads, and access to a wider range of orbits. That combination positions it strongly for both current smallsat missions and future growth into larger vehicles. Reusability. From this graphic, we can see that RFA has already put engineering work into a reusable vehicle concept capable of lifting around 100 tons into orbit. This was part of a study funded by the European Space Agency. It is only a concept at this stage, but it clearly shows the direction RFA is heading. RFA's existing technology, particularly its high-performance oxygen-rich stage combustion engines, gives the company real credibility if it decides to pursue a heavy lift vehicle in the future. Isar, by contrast, has no public concept or stated plans for reusability. Spectrum is a two-stage expendable rocket. Without a path to reusability, it's difficult to see how Isar Aerospace can compete with other launch providers, even in Europe, and has no chance whatsoever to compete globally. Funding. Isar Aerospace is well funded. It is a pure-play venture capital-backed startup that has raised over $900 million from investors. RFA, by contrast, has raised much smaller amounts of private capital. RFA does, however, benefit from substantial support from Germany, the European Space Agency, and the UK government. The company is a spin-out from OHB, a major German satellite manufacturer, which gives it access to established European supply chains for structures and other components. Its deep ties to the traditional European space industry, combined with UK funding and Scottish operations, stand in clear contrast to Isar's pure venture capital approach. Isar has no legacy industrial parent and no significant presence in the UK ecosystem or funding channels. Final thoughts. RFA and Isar Aerospace have taken clearly different approaches. RFA chose to do the hard engineering work up front on a complex but high-performance engine. That decision should give them an easier path to larger, more profitable vehicles in the future. Isar Aerospace chose a simpler engine so it could reach flight sooner, build launch cadence, reliability, and credibility, and then use customer revenue and additional funding to develop more powerful engines for a larger vehicle later. I would characterize RFA as taking the long-term approach, while Isar is focused on getting to orbit quickly and funding future growth from that success. RFA already has credible concept work and existing high-performance engine technology that could support reusable heavy and super heavy vehicles. Isar Aerospace has no stated plans or technology for reusability or larger vehicles. In addition, severe range restrictions and difficult operating conditions at their Norway launch site limits launch opportunities. Isar Aerospace cannot support future constellation management tasks from Andøya, although a future Canadian spaceport would improve that situation. Overall, RFA is better placed to support Europe's need for sovereign access to space. It offers the potential for higher cadence, more mass to orbit, a wider range of mission profiles, and an orbital transfer vehicle for precise satellite placement, capabilities Isar cannot currently match. RFA also operates from Scotland with UK funding and access to UK talent and the wider space systems ecosystem. Given that Scotland is one of the few realistic locations in Europe for a future heavy or super heavy launch site, RFA is well positioned to scale its operations. It certainly is exciting to see a fully assembled orbital rocket on the launch pad in the UK. We could be just weeks away from a commercial launch to orbit from Europe. Are you looking forward to seeing the launch of RFA ONE from SaxaVord? Which company will be the leading commercial space startup in Europe? Is it RFA, Isar Aerospace, or perhaps PLD Space? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoy space videos and want to support independent coverage of the space sector, you can get early access to every new video on Patreon, along with ad-free viewing. You can also buy me a coffee to help keep the channel going. Links are in the description. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.